She may contain the urge to run away, but hold her down with soggy clothes and breeze blocks. Cetirizine, your fevers greet me again. Never kisses, or do you ever send a full stop? Do you know where the muffins go? They go along to take your honey. Way down how we...
Okay, another important skill that you need to know in Pre-Calculus 11 is how to graph lines. So you remember we did this at the end of grade 10. So here's some review for you. All right, I think I have 6 or 7 examples here. The first type, y equals 2/3 x plus 6. Hopefully you recognize that this is in the form y equals mx plus b. This is slope-intercept form, right? This right here is the slope, and this right here is the y-intercept. We love it when equations are in this form. We can just go ahead and graph them right away. Okay? What else to say? Oh, a car just crashed outside my house. Oh, that was a loud noise. I can't see it, so I won't go running out to help, but in the distance I could hear a car crash. Y equals mx plus b, right? And there's your, there's the slope is the m, and the y-intercept is the b. So in this case, slope is 2/3 and y-intercept is 6. So let's graph that. Here it is, y equals 2/3 x plus 6. The y-intercept is 6. So I go up 1, 2, 3, 4, 5, 6, and I put a dot. And then my slope is 2/3. And remember, slope is rise over run. So I'm going to start at this point, the y-intercept. I'm not going to start back at the origin. I'm going to start at the y-intercept. You're going to do the y-intercept first, which is 6. Then I'm going to rise 2. I'm not going to put a point yet. I'm just going to keep my pen there. And I'm going to run 3. 1, 2, 3. There's my next point. If I want to do another one, I'll do it again. Rise 2, run 3. 1, 2, 3. Okay? Remember, if I go back here, the other way I could have moved is I could have gone down 2 and left 3, because that's 2 negative moves. Down 2 over 3. 2 negative moves make a positive. And before I graph it, let's think about this. Is this a positive slope or a negative slope? This is a positive slope. Because remember, think about a businessman or business person, and this is their profits. Profits are going like this. Is that positive or negative? That's positive, so it's a positive slope. Okay, we're ready to graph this thing, so I grab my line, and you can probably do it faster than me. It's a little awkward on the smartboard, or the software I'm using here, but it would end up looking something like this. Done. Put some arrows on the end, so I need to put an arrow down here. And we're finished. Good enough. I know it shouldn't be red, but whatever. Okay, down the first one. The second one, y equals negative 3x. So believe it or not, this is also in y equals mx plus b form. The number in front of the x is the slope. So here's my slope right here. And the constant amount after the x is the y-intercept. Wait a minute, I don't have anything here after the x. So what is the y-intercept? Well, I could have something there. I have like plus 0. I could put that there. So the y-intercept is actually 0. Okay, so we're ready to go. Let's head to that question. There it is, y equals negative 3x, and we've said that it's kind of like negative 3x plus 0. So we can put our y-intercept at 0, and then our slope is negative 3. But remember, when we think of slopes, we like to think of them as fractions. So this is negative 3 over 1. Okay, there is our rise number, and here is our run number. So I'm going to rise negative 3. Rise negative 3. Well, that means I'm actually going down. 1, 2, 3. And then I'm going to run 1, and that's my next point right there. The other way I could have done it is I could have gone up 3, 1, 2, 3, and to the left 1. Either way, once you've graphed a few points, you want to look at it. You want to say, is that going to make a positive slope or a negative slope when I join those together? And that's going to make a negative slope. That's what we want. It's negative 3x. So we're good. I can go ahead and get my line. So it's going to look something like this. We're going to put arrows on the end of both sides. I'm not going to do it. You throw some arrows on the end if you're following along. Okay, there you go. Third one. y equals 4. Believe it or not, this is in slope-intercept form. So the slope's always right in front of the x. We have no x here. So what does that mean the slope is? That means that the slope is 0. And the constant is the y-intercept. So in this case, the y-intercept equals 4. Okay, there's another way you can also look at this. Another way you can always graph is you can always make your t-table with an x and a y. You could have done that back up here as well. So in this case, y equals 4. Y always equals, like y equals 4. There's nothing else that y can be. Y is always 4. What can x be? Anything. No matter if I put -2 here, y is still 4. Or if x is 0, y is 4. Or if x is 3, y is 4. If x is 10 million, or I can't fit 10 million, 10,000, y is 4. Y is always 4. Okay, so there's two ways you can think of it. You can kind of think of all the points where y has 4, or you can think of it with the slope is 0 and the y-intercept is 4. Let's look at both of those. So we go up here. Okay, y is 4. So let's think of it the second way first. I said that one way you could do is look at different points, like, I can't remember which points I said. -2, 4, 0, 4, 3, 4. Let's graph those points. -2, 1, 2, 4. 1, 2, 3, 4. 0, 4. 3, 4. 10,000, 4. 10, 4. 4, 4. Everything goes up in this line. Or the other way you could think of it is the y-intercept is 4 right here, and the slope is 0. And the slope of 0 means a horizontal line like this. Okay, it's not perfectly straight, but you get the idea. That's the graph of y equals 4. Remember, if you forget whether a horizontal line has a slope of 0 or no slope, well, what letter could I turn this one into? I could turn this horizontal line into a Z, and spell 0. So this horizontal line must have 0 slope. Okay, let's do the next one. This isn't working so well today. Okay, x equals -5. That's not really in slope-intercept form, because we like to have y equals to have slope-intercept form. So this is something completely different. But it's very similar to this, because this time we could do our table, x, y. Instead of putting 4, 4, 4, 4, 4, what I know this time is x is equal to -5, -5, -5, and I could throw anything I want in for y. I could put -4 in there, I could put 0 in there, I could put 2 in there, I could put anything I want in there. So let's go take a look what that looks like. Okay, so I said x, y, -5, -5, -5. Can't remember again. Was that right? Is that what I said? I might have said -4. I can't remember. Anyway, x -5, 1, 2, 3, 4, 5, and y -2. Second point, x -5, y 0. Third point, x -4, y 4. Another point, x -5, y is 10. X -5, y is -4. See what's happening? They're all ending up this time with a vertical line like this. Okay, so if you have y equals and then just a constant, you're going to get a horizontal line. If you get x equals and then just a constant, then you're going to get a vertical line. Can't remember whether this is going to be a what the slope is of this line. What could you write? What could you turn this into? Well, you could turn it into an n for no slope. So that's one way you can think of a vertical line, is that it has no slope. Or you could also turn it into a U, kind of. It's not quite as nice, but you could turn it into a U for undefined. It has an undefined slope. Undefined slope and no slope are the same thing. Okay? But the important thing is if you have x equals constant, it's vertical like that. Okay, we're moving along pretty nice here. Now we get to the more difficult ones. Next one we have is 2x minus 3y equals 12. Okay, this is not at all in slope-intercept form, right? It's not in this form, y equals mx plus b. So there's two ways you could deal with this, I suppose. One way is you could turn it into y equals mx plus b. In other words, get the y all by itself, and your y, you want the y to be positive. So if we were going to do that, do you see that I could move the negative 3y to the other side, and that would give me 3y. So I'd have 2x equals 3y, because when the negative moves to the other side, it becomes plus positive 3y, plus 12. Then I could move the 12 over, and it's going to become minus 12. So 2x minus 12 equals 3y. And then I could divide by 3. And when I divide by 3, a good way to think of it is you're dividing everything by 3 like that. So you end up with 2/3 x minus, what's 12 divided by 3? It's 4, right? 12 divided by 3 is 4. And you're just left with y over here. So equals y, or I could put the equals y on this side. Okay, perfect. This is exactly in slope-intercept form. We now have our y-intercept, and we have our slope, and we could go ahead and graph it. But there's another way we could also do it. I don't know if I should do this that way. Okay, I'll do it. Y equals 2/3 x minus 4. That's what we turned it into. So let's take a look at that first. We turn this into y equals 2/3 x minus 4. Didn't we? Sorry, my memory's so bad, it's pathetic. 2/3 x minus 4. Yes. Okay, so our y-intercept is negative 4. 1, 2, 3, 4. Slope is 2/3, which means we're going to rise 2 and run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3. And go as many times as you want. Run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3. Okay, that's more than enough. We can now draw the line. Line's going to go something like this. And I'll extend it on the other side. And throw some arrows on the end, and you're done. Okay, but I want to show you there's another way you could graph this. So let me get rid of the equation, and we'll show you another way you could have done this. Another way you could have done this is you could have found the x and the y-intercepts. X-intercept and the y-intercept. Okay, the x-intercepts are where the line crosses this x-intercept, right? This is the x-axis. Sorry, where the line crosses this x-axis. This is the x-axis, this is the y-axis. For every point on this x-axis, what's the y value of every point on this x-axis? What's the y value? Like this point here is -2, 0. And this point down here is -8, 0. And this point here is 1, 0. You see that every single point on this line has a y-intercept of 0. So if you want to get the x-intercept, what you can do is put 0 right into the equation where the y is. I'm going to put 0 right there. So what does that mean now? Well, it means I have 2x minus 3 times 0. What's 3 times 0? 0. This is gone. You don't have to worry about this anymore. If you're looking for the x-intercept, just cover up the y's and ask yourself, if 2x equals 12, then what does x equal? X equals 6. 2 times 6 equals 12. In other words, the x-intercept is 6. 1, 2, 3, 4, 5, 6. Yep, that's what we got right there. We got that the x-intercept was 6. Okay, let's erase this and see if we can do the same thing for the y-intercept. Y-intercept. Okay, we're going to ask the same thing. If we're looking at all the points on the y-axis, so on this axis, what's the x value of all those points? What's the x value of all these points here? Okay, well this point here is 0, because you're not moving to the left or right, you're just moving straight up. So 0 to 6. And this is 0, 4. And this is 0, -1. Do you see? All the points, every point on the y-axis has an x value of 0. So if you want to know the y-intercept in this equation right here, you can put 0 into the x. So you end up with 2 times 0, which is what? 0. Again, you don't even need to worry about this. This is gone. But unfortunately, I have kind of scribbled just a little too much because I want to make sure you can still see that negative sign there. Okay, so if we're looking for the y-intercept, you can just cover up these x's here because that 0 goes in there, it's gone. And I have -3y equals 12. Well, if -3y equals 12, what does y equal? If you can't figure it out, divide both sides by -3, but you've probably got it. It equals -4. The y-intercept is -4. So let's find that point. The y-intercept is -4. 1, 2, 3, 4. Hey, what do you know? There it is. That's it. That's all you need. You only need 2 points. So using the y-intercepts, you could have found this point, and you could have found this point, and then just drawn a line between them, and you're finished. Okay? Great. Okay, back to the start. So this first, these ones here, those 3 there, that's terrible, but those are all slope-intercept form. There's 2 other forms we learned last year. The one we just did is almost in the next form, but this one truly is in the next form. This one is called general form. Remember, with general form, there's no fractions. It equals 0, right? There's 0. And A is positive. What am I talking about? A is positive. Well, the actual form of general form is AX plus BY plus C equals 0. So there you go. Has to be 0 here. A and B and C cannot be fractions or decimals. So that has to be whole numbers or integers. And A, in fact, can't be even an integer. It has to be a whole number. A has to be positive. See, the 2 is positive here. Okay, so how do we graph general form ones? Well, there's 2 ways you could do it. Again, you could switch it into slope-intercept form, get the y all by itself. So I'll leave that for you if you want to do it that way. Well, what the heck, I'll show you. I would leave, since the y's are positive, I would leave the y's on this side, the 5y, and I'd move the other 2 things to the other side. So the 2x would move over and become negative 2x, and the 15 would come over and become negative 15. Then I'd divide everything by 5. So I'm left with, those cancel out, y equals negative 2 over 5x minus 15 divided by 5 is 3. Okay, so you could graph that. Or the other way you could do it is you could turn this general form equation, you could very quickly turn it into this form here. This form doesn't really have a name, but you could move the constant to the other side. So that'd be very quick to do. Let's go to the actual page here and let's do that. Okay, so I'm going to move the 15 over, the constant over. So I get 2x plus 5y equals, move the 15 over, I get negative 15. Okay, now I'm going to look for the x-intercept and the y-intercept. If I'm looking for the x-intercept, what can I do to the y's? I can just cancel them out, right? So I'm not even interested in this because I'd put 0 into there. So all I'm left with is 2x equals negative 15. If 2x equals negative 15, what does x equal? Negative 7.5. Now I've done it. This isn't going to work. Okay. Sorry. Negative 7.5. Now, if I'm looking for the y-intercept, what's that mean the x value is? That means that the x value is 0. So I can just ignore this. And I'm left with positive 5y equals negative 15. Well, if positive 5y is negative 15, then y equals negative 3. Okay? This will still work. Even though there's a decimal there, it'll still work. The x-intercept is negative 7.5. 1, 2, 3, 4, 5, 6, 7.5 right there. I mean, it's not so good if you get decimals like 7.183 or something. But if you get like halves like this, it's not bad at all. And the y-intercept is negative 3. 1, 2, 3. There you go. You got enough information. You can now draw your line. Click the line here. Well, you take a ruler. Like that. And like that. Put some arrows on the end and you're finished. If we go back, what did we turn this equation into? Remember we changed it into something? We changed it into, I rearranged this, and I rearranged it into this. Y equals negative 2/5 x minus 3. Y equals negative 2/5 x minus 3. Come on, I can do it. Y equals negative 2/5 x minus 3. Let's see if it works, because it should. It better. This is another way we could have done it once we'd switched it. So here is my y-intercept, negative 3. 1, 2, 3. Okay, good. And then my slope is negative 2 over 5. So there's 2 ways I could do that. I could either go down 2 1, 2, and over 5. 1, 2, 3, 4, 5. That looks pretty good. I think that would have worked. Or it could have gone up 2, 1, 2, and left 5. 1, 2, 3, 4, 5. Absolutely perfect. It did work. Okay, so there's more than one way to do these things. You just need to figure out which way you like and go for it. Last one is like this. It's not very common, I would say. This is probably the least common form that you see. This is slope point form. Why is it slope point? Because you're going to have the slope, that's the part just in front of the brackets here, and you're also going to be able to get 1 point, and you get the point from these two parts here. You get the x value from here, because there's an x, and you get the y value for here. Now, I don't want to go into too much detail right now about why this is, but you might remember from last year, you actually kind of take the opposites. The reason is because the equation is y take away y1 equals mx take away x1. That's the equation. So here's your slope. M is always slope, right? Okay, if it's x plus 5 here, if it's plus 5, what must the x1 value what must that value have been? Well, it can't have been positive, because then you have x take away a positive, and that doesn't make a positive. It must have been negative, because x take away negative is positive. Confusing, right? But remember we said last year, we said it's always kind of the opposite. That's the other way you could think of it. So if it's x plus 5, the x value of the point is minus 5. And if it's y minus 4, the y value is positive 4. Why is it positive 4? Because which number would I put in right here? Y take away what would be y minus 4? Well, y minus 4. Just 4, not negative 4. Because if it was negative 4, it would actually become positive here. I know. As I said, just take the opposites. Negative 5, positive 4. So the point is negative 5, 4, and the slope is negative 1/2. Let's graph that. We said the point was negative 5, 4, so we can graph that point. Negative 5, 1, 2, 3, 4, 5, and 4. 1, 2, 3, 4. And the slope is negative 1/2. So rise and run. Okay, so I can either rise negative 1, meaning go down, and over 2, 1, 2. Or I could rise positive 1, and then run negative 2, like that. Either way, it should be a negative slope, right? And this is a negative slope, so I've done this correctly. Then I'd get my ruler. Whoa, that's nice. Really nice job. Okay. Is there another way to have done this one? Yeah, there is. You probably wouldn't do it this way, because hopefully you'd recognize this. But you could, again, switch it into y equals mx plus b. Let me do it real fast. It probably won't even be worth the effort, because you'll get confused by it. But let's see. We could do the mountains here. So I get y minus 4 equals negative 1/2 x. Take away 5/2. I'll leave it for you to convince yourself that negative 1/2 times 5 is negative 5/2. Then I could move the 4 over. So I get y equals negative 1/2 x, take away 5/2 plus 4. Negative 4 becomes plus 4. Then I could combine these two terms. So I get y equals negative 1/2 x. This is the same as 4/1. So I could change 4/1 to 8/2 to get common denominators. So negative 5/2 plus 8/2 is positive 3/2. Okay, let's see if it worked. It's not going to be totally accurate because my line's so pathetic. But the y-intercept is 3/2. That's the same as 1.5. 1.5. Yep. And the slope is negative 1/2. So I could either go up 1. Now careful. Going up 1 takes you to here, right? That's 1 above right there. And over 2. 1, 2. So right there. Or I could have gone down 1. That would be right down to here. And over 2. 1, 2. It worked. Join them together with another lousy line. That's better. And you have your line. So I could have done it either way. But I hope you agree with me. It's much easier if you can just pick out the point and the slope there. All right, that's a lot of information for you, but hopefully it jogs your memory a little bit. And that is how we can graph lines.
She's Flutter's pistol shots, hold her down when soggy clothes and breeze blows. She's morphine, queen of my vaccine, my love, love, love.